when you graph them cross, because the point where they cross is the answer that solves both of them, and there's only going to be one point there. So when you solve by graphing, your first step is you need to graph both lines. And it's not very hard. And I don't know how long it's been since we've actually done some graphing, but there are a bunch of ways to graph lines. Does anybody know one? The most difficult one, or the most tedious one, is to graph it by making a table like I did here. That takes the most time. How else can we graph it? There's two other ways. Steph, one was
like in standard form, you like put 0 as graphs.
standard form, which I would use on this one here. I wouldn't use that for both of these. What form are these in, and how did we graph them before? By the way, you can always make a table if you don't get this. All right. These both are in slope-intercept form. And to graph them, do you remember doing this? Let's say I'm graphing this first one, y equals x plus 3. Where does it cross the y-axis? Do we not remember that? The number 3 is the y-intercept, so here at 3, you put a dot because that's where it crosses the y line. And then what is the slope? Wow, has it been that long? Slope is the number in front of the x.
1.
Thank you, it is 1.
Yeah.
Which means you need to make it a fraction. What is 1 as a fraction? 1 over 1, which means this line goes up 1 over 1. So from this point you already have up 1 over 1, up 1 over 1, up 1 over 1. It's a positive slope, so I picked this side, otherwise I would have picked the other side. And there, children, is my first line. Yeah, I missed it a little bit. And it is imperative, oops, sorry. It is crucial that you be as perfect as possible with your lines, because if you get off with your lines, your answers are going to be wrong. So you should have that there. Parker, will you close that door? You need to graph the other line, which is y equals 2x plus 1. What's the first thing I do on that line? Where does it cross the y-axis?
1.
That's your y-intercept right there. So at 1 you put a dot. And then what is the slope? What number's in front of the x? So you make it a fraction. It goes up 2 for every 1 over. Okay, so you go up 2 over 1, up 2 over 1, up 2 over 1, and then you draw a line there. And we can only hope that I get this right. And in this case here, and then the answer is, where do they cross? What point do they cross at? And they cross right here at 2, 5. Is that right? Is that what you got? And this is the only point that solves both of those linear equations, and that is the complete answer for that. Solves that system of equations. So it's really not very hard, you just got to be able to graph a line. Got it? Now, when you have systems of equations, there are 3 possibilities. We already did the first one where they actually do cross. And where they do cross, you get one solution. Okay, you get just one solution there. Let's look at example 2, mind you, children. And again, take a look at the equations and see which way you want to graph it. Steph said there's xy intercepts, there's slope intercept, and then there's just making a table. You can always make a table, but this one here is in what form? It's in slope intercept, so you use slope intercept. It crosses at the, let me write it down, y equals negative 1/2 x plus 4. It crosses y at 4, so you put your little dot there at 4. What is its slope?
-1/2.
Negative 1/2. Now make sure if it's negative 1/2 that your line goes downhill, it's not going uphill. So when I go my up 1/2, I have to go this way, because that makes a downward slope, up 1/2. And the more dots you put on this, probably the more accurate your line is going to be. So don't be afraid to keep going up 1 or down 1/2 until you get a whole bunch of them so that you get a good line. If you just do 2 points, sometimes you can kind of get a little mixed up. Does that look right? Does yours look like that? Looks like I need to go up a little. Go a little more like that. It doesn't want to go there. Let's just call that good right there. The second line, ladies and gentlemen, kids of all ages, notice this equation is not in slope-intercept form. It's not solved for y. You could always solve it for y and do slope-intercept, but this one would be very easily graphed by the xy intercepts that Steph talked about. How do you do xy intercepts? Well, if you put 0 in for x, x goes away, what would y equal? If 2y equals 8, y equals 4. So there's your 0, 4, there's your y-intercept. Oh boy, it ends up at that point here. If I put 0 in for y, 0 in for y, it goes away and you're left with x equals 8. So there's your second point. And if you go there and you put your dot there, lo and behold, for this line here, children, it's the second example. What do you get?
Same.
You get the same line. Now, what would my answer be for this then?
What, like where it crosses?
Mm-hmm.
Our solution?
No, it does have a solution.
Zero comma. Anyone with 0 comma.
It is infinite solutions. Because these lines keep going on forever, any point on that going in forever direction would be an answer to it. So if it's the same line, this one they crossed, this one they're the same line. If it's the same line, then you just say it's got infinite solutions. Because there is no one set answer for it. And then our last case, example L number ultrao. If I'm doing this one, both of these are solved for y, so I would use slope-intercept for both of them. And really, it shouldn't take you very long to graph these. First thing I do is put a dot where? Alyssa Smiley? Where? Say -3? -4 on the y-axis, so I put a little dot there at -4. My slope is a positive 3/1.
So up 3.
Perfect. Up 3/1. It's positive slope, so you got to go this way. Up 3/1. Up 3/1. Up 3/1. And there, children, is our line. If you got a little foresight on this, you might be able to tell me what's going to happen here. Y equals 3x plus 2 is my other line. Crosses the y-axis where? Yes, 2. Thank you, Jake Vickery. What's my slope, Jake? Yeah, make it a fraction, 3/1. What's going to happen? It goes up 3/1, up 3/1, up 3/1. Oops, that was over 2. Up 3/1. And when I graph this line, I get my second case, which is what happens here? They never cross.
So no solution.
There you go. No cross, no solution. This apparently doesn't like what I'm at here. Don't cross, no solution. Okay, So those are your three cases. Either they never cross, they're the same line, or they cross. Now what can you tell me, what little fact do you know about these two cases here?
If they're the opposite.
No, they're not opposites.
Well, those ones are like the opposite.
What do both of these cases, what do the lines have in common in these? They
go
have
in
the-
same direction. Like positive and negative, like both positive and negative.
Yes, but not only that, in both cases, these lines have the same slope.
They go in
Okay, slope in both of these were the same, just cross the y-axis at different places. If that's the case, it's gonna be no solution. In this case, the slope was the same, you couldn't tell because it wasn't solved for y. But in this case, the slope is the same and the y-intercept is the same, they're the same exact line. But in both cases, if you see that the slope is the same, you know it's gotta be one of these two things. If they have different slopes, then they're always gonna cross somewhere. If the slopes are different, there will be one answer. So you know if one's got a positive slope, one's got a negative slope, that you're gonna get an answer. Even if they're different slopes and they're both positive, you're still gonna get an answer there. So that, ladies and gentlemen, is your three possibilities within your equations. And now I know you say, hey, why